Welcome everybody to this next presentation in the series of Community of Practice webinars. This is the sixth year that the Risk-Informed Performance-Based Principles and Policy Committee, that's what RP3C stands for of ANS, has been putting on these events. Presentations and recordings of the events are available to the public at the ANS website under the tab RP3C. There are now over 50 such recordings available. The purpose of these webinars is to offer practitioners of concepts and methods related to risk-informed and performance-based approaches, RIPB, a chance to share their knowledge and experience. I would expect that such practice will be used for implementing nuclear technology and evaluating its safety and effectiveness. The purpose of RP3C is to help modernize ANS standards. Recently, there has been a combination of legislation and executive actions that make now an opportune time to pursue modernization of all activities associated with nuclear design, operation, and standards development. The NRC has shown great willingness to receive submittals which employ the full range of RIPB techniques. They've stated that they are looking for a demand signal from industry submittals to exercise all the methods currently available. There is growing realization within the nuclear community that conventional, prescriptive, and deterministic approaches are not going to support increasing use of nuclear technology to play its rightful role for the benefit of society. Socializing alternative approaches could drive changes in industry and regulatory practices. ANS offers the COP files on its website to serve as a knowledge repository of experience from a wide range of practitioners in the field. We hope that more people will use this knowledge base to pursue modernization of all the activities. This will speed up needed changes in the state of the art as well as the state of practice. These events are generally scheduled for the last Friday of the month. Today, we will hear from Bill Reckley, who has a distinguished career with the NRC and recently retired. Bill has made a presentation previously on the community of practice when he addressed Part 53 in the proposed rule stage. Bill is now a consultant, and he will, as part of his presentation, I speak about Part 53 and the role that he has played on it. So, Bill, thank you very much, and please go ahead.
Okay, thank you, Prasad. The topic of systematic risk evaluations has been introduced into some of the recent changes to NRC regulations and related guidance being prepared by both the industry and the NRC. The most familiar type of systematic risk evaluations for at least the nuclear power industry is probabilistic risk assessments. But recent activities, new design proposals, legislation, as Prasad mentioned, a host of things have led to questions on how other risk evaluation techniques might be used either in combination with PRAs or as an alternative to PRAs in risk-informed decision making. As Prasad mentioned, I'm retired after a few decades of working at the NRC, and I'm here just to provide some of my own personal perspectives on the topic. As mentioned, before my retirement, I worked on Part 53 from its beginning up to almost its issuance as a final rule. Um, I will also caveat I'm not a risk analyst or a PRA analyst, and I instead depended on smarter folks when I was working on licensing and policy issues. So I have a perspective, but um, sort of as a somebody on the outside as opposed to a detailed PRA analyst. So systematic risk evaluations, including probabilistic risk assessments, are used in risk-informed decision making related to plant design, licensing, and plant operations. These evaluations and the related design choices and the choices on operational programs can be viewed within the context of risk management. I don't think this is a new concept or even the terminology is not necessarily new, but just putting it into that context of risk management is something that we don't often do uh, in my experience um, with the industry and at the NRC. So one can find different definitions of risk management. They are all similar, and I like this particular one. It's from the Department of Homeland Security Risk Lexicon. And it simply states that risk management is the process for identifying, analyzing, and communicating risk, and then deciding if it's going to be accepted, avoided, transferred, or controlled, all to reach an acceptable level of risk, considering the associated costs and benefits of the actions taken. So again, I don't think there's anything probably earth-shattering in that, but it it puts puts one in the mindset of what we're trying to do, which is to control the risk, and in our particular case, to control the risk associated with um, the design and the deployment of um, nuclear power plants or other uses of radioactive material. Risk management has evolved over many years, just like PRA has. And it's now a broad field, um, and it's matured through its applications to both industries, financial institutions, insurance, a big user, and many other areas. And as such, when you look at um, general guidance, like the guidance in ISO 31000 risk management guidelines, if you look at that standard, there's a very general discussion of risks because it is talking about how to develop programs for any of those activities, be they public health and safety or financial or other potential adverse results. The principles within ISO 31000, again, I don't believe they'll be unfamiliar, but it starts to talk about um, how things could be considered, and we'll get to this later, systematic. And that is, it's integrated into the organizational activities. It includes structured and comprehensive assessments to ensure that you can get consistent results. One thing that's a little bit um, different in risk management as opposed to maybe traditional licensing of nuclear power plants is it anticipates and sets up ways to detect, acknowledge, and respond to changes. So it has to be effective, it has to be a dynamic kind of program um, um, versus, again, what may have traditionally been um, at least intended to be somewhat static way to address safety and regulations for the operating fleet. And then another one there on the chart is it has to be based on historical and projected information and to address uncertainty. So these are just basically higher level principles that go into developing a risk management approach, a risk management program for an organization. So I personally was lucky enough to be involved in a task force with Commissioner George Apostolakis and another group, a great group of individuals working on a project that led to the issuance of NUREG 2150, which was a proposed risk management regulatory framework. You can see the date there, 2012. It's hard for me to believe that was, 15 years ago. And it kind of was overtaken by events with Fukushima happening in 2011. But I'm somewhat gratified at this point to see some of the ideas that was in NUREG 2150 actually being adopted, albeit 15 years later, in some of the new rules that are just coming out in the most recent proposals for modernizing regulations and oversight um, uh, at the NRC. That effort in 2150, NUREG 2150, included the development of a risk management goal. And again, this at the time was for all NRC activities. So power plants, radioactive materials, fuel cycle waste, uh, all of the activities. But basically here on this slide, it just reads that a risk management goal could be to provide risk-informed and performance-based defense and depth protections. 2, ensure appropriate barriers, controls, and personnel to prevent, contain, and mitigate exposure to radioactive materials, and ensure that the risks resulting from the failure of all or some of those barriers and controls, including human errors, are maintained acceptably low. Again, so I'm not thinking that's particularly unusual for people to see. It's got all the typical words. Barriers, controls, and personnel are the way you achieve your results. You need to prevent and mitigate events. You need to include or consider what hazard is actually present, what are the relevant scenarios, and so forth. And again, importantly, consider uncertainties. Um, and now we get to actually a risk management process. And I know the title of the presentation was Systematic Risk Evaluations, and this is where you start to see the title come into play. There are any number of references by ISO in ISO 31000, government agencies. Again, I'm referring here to a figure from the Department of Homeland Security, but other government agencies, industry organizations, and others that have defined and reflected a risk management process in a figure. And they are all very similar. And basically, they involve steps to identify internal or external hazards, that could cause harm or loss, analyze how likely the risks are to happen and how severe the damage could be, to evaluate the risks by ranking and prioritizing them for some kind of preventative or mitigative action, or by comparing them to some established design criteria that could help determine what action would be needed, if any. And then the next step would be to implement a strategy that involves those appropriate actions based on the decisions that you made in the previous step. And those decisions, again, going back a couple of slides, could be to avoid, to manage, to transfer, or simply to accept the risks that are coming out of the analysis and the evaluation. And then importantly, the last step is to monitor the risk over time and update the analysis, update the actions taken as necessary to reflect either changes in your understanding, changing in the performance of the actions that you took. So you can see in these figures that risk identification, risk analysis, risk evaluation are really important and to some degree at the heart of a risk management process. One can identify approaches that are commonly used in the nuclear industry, and you can relate them to some aspect of risk management processes. All or many of the approaches within the industry involve not only doing the design and the analysis, but then also including surveillances and monitoring of performance, for example. There has been increasingly over the years a trend to use more processes like this. And so you can look at Reg Guide 1.174 for risk-informed decision making for the operating fleet, or 5069 on categorization of SSCs. And you can see these kind of thoughts being woven into those processes. So again, not really an earth-shattering revelation, perhaps, but just a different context and a different way to organize thoughts. So another figure from NUREG 2150 goes to the deliberation step. And this figure shows you get an important input into the deliberation process from the risk analysis. And then that points over to the ISO 31000 description of what does come out of a risk analysis. It involves a detailed consideration of the uncertainties, various inputs to the risk, the consequences, the likelihood, and the controls that are in place for their effectiveness. So that is the analysis part. And then the other parts of the figure are other things are going to go into deliberation. You're going to have input from stakeholders. You're going to have resource and schedule constraints, other outside factors. So it's rare that you will get just a easy decision that comes only out of the risk analysis. So the deliberation process includes those other factors. But in terms of the risk analysis, the process does include a specific evaluation of those analytical results, and that is a comparison of the results to an established risk criteria. Again, this just goes to being systematic in that you decide on your risk criteria, then you do your risk analysis for the comparison. You're not just ad-libbing this as you go along, as one might say. So an example in the nuclear industry would be a decision, or well, one, the risk analysis, including the use of the probabilistic risk assessment to estimate the risks or the delta of risks for a particular item, and then a comparison once you've done that analysis to something like the NRC safety goal, which would define the criteria by which you're making the decision. So most of us that have been around a long time have seen that play out in any number of cases where an issue arises, the risk analysis is done, and then the decision is either additional action is warranted or perhaps more often, no additional action is needed. We'll just accept the risk um, as it was analyzed. So as Prasad mentioned, I did work on Part 53, so not surprising that this is the example I'm going to use in the next couple slides is from Part 53. We did consciously consider risk management ideas as we were developing Part 53. And that was in part because Part 53 is designed to be largely self-contained. And so it had to address kind of the whole cycle of risk management and the whole cycle of a facility, the lifetime of a facility. So in the case of the licensing of a new nuclear power plant, a designer will use different approaches um, of different complexities to evaluate and iterate on various elements of a design. Um, and again, that's going to consider a lot of different factors from the designer's perspective, not only just safety and risk, but also economics and technology readiness levels and all kinds of factors. But they're going to use all of those things and they're going to come up with a design and associated activities that are going to need to be done during plant operations. So operating programs. Um, Within the licensing modernization or LNP methodology that most of you are familiar with, I think by now, the design would fall into the plant capability area and the programmatic controls would be addressed in the programmatic defense in depth areas and include procedures and personnel, surveillances, and those kind of things. Also, I think from previous discussions, Part 53 was developed such that the LMP would provide one acceptable way to meet many of the requirements within the rule. So it really wasn't a coincidence that you see similarities between what Part 53 requires and Part 53. So within the risk management process figure, the analysis step is largely addressed through the regulation in 53.450 analysis requirements. And it's read here that you are required to have a PRA, other systematic risk evaluations, or a combination thereof. And those requirements are then used for a number of activities that are addressed later in Part 53. So 450 might also address a little bit of the evaluation criteria. We didn't reflect exactly the risk management approach. We brought in some of those ideas, but again, it doesn't map exactly. Um, but you can see the steps are there. So this is the analysis requirement. It defines at least one acceptable technique, PRA. It opens it up to um, other possible approaches, or very likely a combination of the two that gets used. But for the evaluation, 450 also points to the acceptance criteria for the risk analysis. So this is what would be under the ISO 31000 involved in the risk evaluation step. You analyze it and then you compare it to the acceptance criteria, which are defined in 53220. And I won't read it. You've had other sessions on part 53, but it basically says that you compare your risk analysis to a comprehensive risk metric that is compared to an associated risk performance objective, and that is the part of the risk evaluation. And then under A, you also use that risk analysis to confirm you have defense and depth and meet other evaluation criteria. So many of you will probably recall that the first proposal from the NRC staff was that B would be fairly specific, and in that in the risk metric was proposed to be early health effects and prompt fatalities, and the risk performance objective was the NRC safety goals. Stakeholder comments led to that being changed to open it up to consider other risk evaluation techniques, and that's reflected in the final language there that says systematic risk evaluations as a possible process, not defined, and comprehensive risk metrics and associated risk performance objectives, again, not defined. That would be up to the applicant to propose. But the rule goes on, at least in the preamble, to explain what is meant by some of this terminology. So I just list them quickly here. Comprehensive risk metric should approximate as well as it can the overall risk from the facility. It is possible to use screening tools or bounding methods for particular modes or hazards. You need to treat uncertainties. One acceptable way is to use the latent cancer fatality and prompt fatality metrics from the NRC safety goals. Or, as I said, they could, an applicant can propose something else, including surrogate measures for the safety goals. And a surrogate measure is like the measures that are typically used for light water reactors, core damage frequency, or large early releases. So you can start to see, I think, in the discussion that the systematic risk evaluations need to address more than just having a methodical method to identify what can go wrong, but also that the analysis and the evaluation of the risks to establish performance objectives and the need then to routinely monitor. So all of this is to say that when you say systematic, and you look up a definition of this term, to me, it's important that it emphasizes the system aspect. That the systematic means that this analysis, this evaluation, is part of the overall risk management framework, and systematic is not simply the alternative to haphazard. So this then gets picked up within the Part 53 model in another aspect of the risk monitoring figures or cycles, and that is in the monitoring aspect. And Part 53 includes some specific uses of the analysis under 53.450. They include ones that are familiar, especially for those familiar with the LMP. You have to use that analysis to identify your licensing basis events. You need to support the safety categorization of your structure systems and components. You need to assess defense in depth. But number 6 says that you need to, another specific use of the analysis is to establish the appropriate measures for plant operation, including how you're going to address availability, how you're going to ensure that the capabilities and reliability of the equipment is consistent with the analysis, and that they all show that you continue to meet the safety criteria. And then that gets picked up during operations by the regulations under subpart F in Part 53 that basically says you need to have a monitoring program to do what was enabled by the analysis, which is to define capabilities, availability, and reliability needs of structure systems and components. Again, not necessarily a new or novel idea. You can see that kind of feedback and monitoring of success or looking for potential issues in things like Reg Guide 1174 that's used for risk-informed decision making for the operating fleet. Likewise includes this kind of monitoring step. But the nice part about a risk management framework, choosing from basically any of those available models, is it becomes part of a systematic and established process. So getting now a little more into the topic of systematic risk evaluations as an alternative to PRA, or other systematic risk evaluations other than PRA as being a possible tool. Another ISO standard is 31010, risk assessment techniques. And this slide just is a high level discussion that leads into that standard, basically saying that you do these actions to meet the principles that were laid out in that previous slide. And I'll skip it just for the sake of time, go on here, but it basically just lays out those principles and says when you're trying to pick the technique that you're going to use for risk assessment, that you consider those principles. But then get into some specific examples. For the risk identification, you'll see fairly familiar things like failure modes and effects analysis, process hazards analysis, or hazard and operability analysis, HAZOP. For the risk analysis techniques, it kind of recognizes that there's different conclusions one might reach. And so you can analyze controls or barriers using a vehicle like a bow tie diagram that just basically says, do I have some measures to prevent and mitigate events, and lays it out um, um, to help analyze it and show it. Or you can lean into approaches like maybe the nuclear industry is more accustomed to, where you do more detailed analysis of actual estimated consequences and estimated likelihoods. And that's going to use PRA-like tools, event trees, fault trees. And then under the risk evaluation part, you can make your decision using criteria. Again, this is to be defined, but it could be and is in many cases laid out as the risk should be as low as reasonably practical. Another way to do that would be to use a cost benefit assessment to see if actions are warranted in light of the risks. You can have frequency consequence or frequency number diagrams. That would be something like given the frequency of a dam failure, I don't want to kill or misplace more than X number of people. Or risk indices. And sometimes depending on the hazard, those risks might be presented in more simply term. Who's used to seeing like a table or a matrix with high, medium, low kind of estimates. Again, depending on the risk and how you want to communicate it, you can use different approaches. Nuclear, being traditionally more complicated, has leaned towards the more complete and more complicated of the processes. I'll just mention, kind of out of interest in history, when I first met Brandon and Steve, it was at a workshop, and I won't say how many years ago, and it was for molten salt reactors, and they had worked on a project and a report that used process hazard analysis to look at a molten salt reactor to support early design decisions and identification of risks. And then the report basically laid out how that risk identification, if you're using the ISO 31010 terminology, how that risk identification would then be very useful when you went to the next step in the process, which was to do a PRA in that particular argument. So, but I'll let it up to Brandon or Steve to correct me if I mischaracterize that. But again, that was a number of years ago. Just a couple more slides here. So the NRC did evaluate one alternative to using a PRA when we were developing Part 53, and some of you will remember that it included a alternative evaluation of risk insights. It was going to be in the more traditional or framework B part of Part 53 that ultimately was removed. But in any case, that recognized that the analysis for large light water reactors included studies and analyses and actions that were strongly influenced by low frequency but high consequent event sequences, like basically the severe accident considerations for new reactor designs. but this particular activity assessed whether it would be possible for some new proposed designs based on lower radionuclide inventories, lower operating pressures, other inherent features to maybe have lower consequences, and whether those lower consequences could be used as an alternative to a PRA. And so the study that was performed by the staff evaluated, could you still meet the NRC safety goals with less focus on estimating event frequencies, like maybe has been the focus for large light water reactors, and instead say, well, the consequences are so low that event frequencies are less important, and we could still show that we meet the safety goals. And the end result of that was a proposal that if you could show that your bounding analysis, your bounding event had a consequences of less than 2.5 rem over the first year within the 10 miles of the plant, then you could forego having a PRA based on that bounding assessment. And that's a couple of the reg guides that were related to that effort are mentioned there. One of which is a Reg Guide 1.254, which is not just applicable to Part 53 or to this particular effort. It's a general guidance document on how one can have a methodical approach to identifying licensing basis events. So this was one, I thought, possible example of a risk analysis approach and a risk evaluation because it remains tied to the safety goals. And it's an alternative to a PRA. And then lastly, on this slide, as most of you are aware, there are a number of activities, large number, that are still going on and that are somewhat related to the topic of systematic risk evaluations because um, uh, because it becomes key how you do the analysis, how do you develop the acceptance criteria, and so forth. So within Part 53, there's guidance that's being prepared on citing on the comprehensive risk metrics. If you're using something other than early health effects and the safety goals, there's a guidance document being prepared on evaluation of different risk assessment techniques for risk-informed decision making, going right to how to look at systematic risk evaluations other than PRAs. Maybe more common is not using something in place of a total PRA, but using it to supplement or address just an aspect of the risk, like a particular mode or a particular external hazard. In that regard, and I think it's been briefed through these community of practice seminars. One area of particular interest is low frequency, high magnitude, high uncertainty seismic events. And that was evaluated in a report prepared by Argonne National Lab on low frequency, high consequence seismic events. And that was recently largely incorporated into NEI 2603 that was submitted for NRC review and possible endorsement. So again, that's not using something in place of a PRA. It's recognizing that PRA has challenges in some areas, including low frequency, high magnitude external events, and using a different approach to address that topic. And other aspects of the risk of the plant largely would be addressed by a more traditional PRA. You also have bounding event approaches in Part 57 and unmitigated events being introduced for graded site characterization. It kind of picks up on approaches than in ANS 2.26 and DOE standard 1020 for looking at ways to have different hazard categories for facilities or even SSCs within facilities. These have not generally been described as a way to meet something like the safety goals, but they probably could be with a little twist of the argument. But they're presented as being bounding approaches. And then lastly, the modernizing reactor licensing and safety oversight has included 5220 and 52220 on alternatives to prescriptive requirements, and it specifically calls out the use of PRAs or other systematic risk evaluations to be used in the justification. So sorry that went a little long, but Brandon, if there were questions.
Yeah, no, I don't think it, no need to apologize at all. I don't think that went uh, overly long. We got time and we got two questions so far, and I'm sure some more will roll in. So I think this pertains to what you just talked about on slide 14. Phil in the chat is asking, was NUREG 2150 specifically included or referenced in new DOE pilot reactor projects? For example, under the dome at Idaho National Lab, such that those safety analyses would already be in conformance with the NRC. That is, if those reactor designs eventually attempt to do commercial widespread NRC licensing. So I think maybe to reframe that in a little bit more general question, as in looking at these supplemental risk evaluations, or thinking back to some of the things that were considered for Part 53, to what extent did best practices or other guidance from the DOE kind of either explicitly or implicitly inform the NRC guidance and practices?
I think we've brought that I got to get out of that habit. The NRC has looked at and used where possible updated DOE thoughts and ideas. For example, the external hazard approach, the ANS standard was largely developed coincident or even to support the DOE standard, and the NRC did not do much with that for a while. But as new applications piled up, it looked like such an approach might be needed, and so you have the graded approach. Another way to address that question is it's really up to the applicant to decide when they're applying for DOE authorizations, whether, for example, they would pick up and use a format for the applications that could then readily be used at the NRC, or would they ask the NRC to look at an application that was formatted for the Department of Energy, or would they just kind of recognize that they are two different authorizations and the formats may vary? But I think they'll try to use as much of the argument as they can, but it really again is largely up to the applicant as to how to maximize the usefulness of the DOE activity in their NRC application.
Great. Yeah. Thank you for that additional information. And then this may go back to slide 7. I mean, I think this is kind of more general in its kind of context. So Steve's asking, or I guess starting out by saying, my recollection is that Part 53 originally focused on PRA, but was broadened to include other approaches like the systematic risk evaluations, due in part to nuclear industry pushback on the requirement to apply a PRA. So to your knowledge, has anyone in the nuclear industry come forward with a fleshed out alternative to PRA, that being a systematic risk evaluation for use in licensing a reactor?
Um, Not, to my knowledge, not as a replacement, but there are proposals, and I mentioned one in the area of seismic, where it would be an alternative to an aspect of a PRA or a supplement to address an area that the PRA has difficulty, which again is low frequency, high uncertainty areas. Um, so those things are there, but I haven't heard of someone proposing to use, I'll just make one up, a bow tie diagram instead of a PRA to basically justify that they have um, addressed the requirement for a systematic risk evaluation. I think people are looking at it, but I've not heard of a proposal actually coming forward.
Bill, just to bring you up to date on ANS 2.26, there is a new revision being worked on, and that revision is going to have specific options, to implement in addition to the unmitigated release option. And one of them is going to be an objectives hierarchy construction, to use essentially Part 53 and 230B, which states that the fundamental safety function is limiting radioactivity release. And so that is, very amenable to construction of an objectives hierarchy. So that's part of what we are working on right now within ANS, and we hope to get our comments in before the end of August for DG 4036. So,
Yeah, there are also specific regulatory guides and that are being prepared. I don't believe they're out for comment yet on um, earthquake engineering to specifically address both the um, seismic hazard analysis and how it's incorporated into the design, and another reg guide on the use of snubbers as part of that strategy. So within Part 53, 53.480, earthquake engineering basically provides that flexibility, but it um, but there were some things that were left to do in terms of codes and standards in those regulatory guides.
So, Steve Cron, I don't have any other questions in the chat. If you wanted to, if you had any that you wanted to ask, or if you were ready to close us out here.
No, I think a good question and answer section. And Bill, thanks a lot for giving us your thoughts on, what is an emerging area of dialogue in the industry. I think that's one of the important functions that a group like this, Community and Practice, can serve, which is a platform for sharing thoughts and tabling ideas. And on that front, I want to put in a plug for next month's speaker, Bob Boston, who is a longtime safety professional and also the site manager at DOE Idaho, and he has been right in the middle of DOE's accelerated review of reactor designs over the last 14 or so months. And we have asked him to come and talk to us about this emergent area of work at DOE, and he has graciously agreed to come and talk to us about what is still emerging work in the Department of Energy. So he has also requested that we not record the session, so that will be a little bit different than normal, because he is talking about ongoing work and wants it to be a fruitful, interactive discussion. So this is even more of a reason to show up live next month, because it will not be recorded. And tell your friends and colleagues that that is the case, and they should all come on down and listen to what Bob tell us about his experience in this pivotal program for the Department of Energy over the last year. So, and Brandon has reminded me it'll be August 28th. So put that on your calendar and plan to be here live for Bob Boston's talk. I'm sure it will be very interesting and very insightful. As I said, he is a career safety analyst who's gone over to bureaucrat in his declining years. So I, I I've known Bob for a long time, and I think he will have a very lively presentation. So thank you all for being here this month, and we will see you next month with Bob Boston. Thank you, everybody. Have a good weekend.